Hello everyone and welcome to this lecture. In this lecture, we are going to train a linear regression model in SkLearn. So let's go ahead and get started. If you guys remember from task number 4, is that we have been able to prepare our training data and testing data as well. And now we split the data and now I have X-train, X-test, Y-train and Y-test, and we're pretty much ready to train our model. So what I'm going to do here is that I'm going to use SkLearn to train our model. So SkLearn is simply a library that could be used to perform a lot of machine learning, basically training. A lot of machine learning algorithms are already built in within scikit-learn. So I could say from sklearn.linear_model, we're going to import linear regression. And then I'm going to say I wanted to, from sklearn, to import some of the metrics as well. So I want to take a look at mean squared error, and I want to take a look at accuracy_score. So to simply fit the data, what I'm going to do is that I'm going to instantiate an object out of my class, and here I called it regression_model_sklearn equals to my linear regression, and here I'm setting my fit intercept to be equals to true. So when I say fit intercept equals to true, that means that I want to have the linear line or the model that I'm trying to fit. It could have a y-intercept. It could have basically a b parameter. If you guys remember, any straight line equation is y equals to mx plus b, right? If I set fit intercept equals to true, that means b could have a value. B could be 3, 4, 5, whatever. However, if I set fit intercept equals to false, you will find that b will be forced to be equals to 0, which means you are forcing the algorithm to fit, when it fits the data, to force the line to go through the origin. Okay, so let's go ahead and start with fit intercept equals to true. And actually in the mini challenge, I will ask you guys to set the fit intercept to be equals to false and let me know what changed. Okay, so here we instantiated an object, and then we're going to apply the fit method on my model and feed it in my X train and my Y train, which is my input data and my output data. Let's press Shift Enter. Here we go. So it's telling me the model has been trained. Everything looks good. And now I can simply go ahead and actually evaluate my model. I can just do like a quick score. So I can say what I could do here. I can say regression_model_sklearn, which is my model here. Please note that this contains all the learnings, contains all the information that I'm looking for. Okay, and I can say .score. I can feed it in my testing data, X-test and Y-test, and I can simply plot here my accuracy. Shift Enter, and here we go. We have been able to achieve almost 96% accuracy on my testing data. Okay. Again, please note that this model is very, very simple, and that's why the model has been able to just train in no time and generate solid results as well. So what I wanted to do right now is that I wanted to see the actual coefficients. If you guys remember, my entire objective is to come up with the straight line equation. I'm trying to find the best values of m and b. That's all what I'm doing, all what I'm looking for. So to do that, I can go ahead in my regression_model_sklearn, which is my model that I trained in here. I can say dot coefficient and dot intercept, and that will return back to me the m parameter, which is my slope, and my b, which is my y-intercept as well. Let's press Shift Enter, and here we go. Now I have basically the model. Now I have trained model. I can take that model and simply deploy it in practice. I can, for example, use that model and give it to HR, for instance, to tell them, okay, if you have a new employee, okay, that new employee you will look at his resume and maybe say, okay, maybe they have, let's say, 7 years of experience. You can plug that in, and that will make predictions. Will tell you, okay, maybe we can give him salary of maybe $60,000 or maybe $80,000 and so on. Okay, so that's the overall idea when we develop any machine learning model, to actually create a model based on historical data and try to deploy it in practice on data that the model has never seen before, and that's what we want to do in practice. And now it's time for the mini challenge. What I want you guys to do, so please go ahead, retrain the model while setting the fit intercept to be equals to false. Please let me know if you notice any changes in the model. Please go ahead, pause the video, and I will see you guys after the challenge. All right, hope you guys were able to figure out the challenge. What I ask you guys to do, so please go ahead and just instead of setting fit intercept equals to true, set that to false. Shift enter, shift enter, shift enter, shift enter, and here we go. You guys will notice that the B parameter here has been forced to be equals to 0. Has to go through the origin, okay? So that's why you will find the slope is very, very different, okay? All right, so that's all what I have for task number 5. I hope you guys enjoyed it. In task number 6, let's go ahead and evaluate our trained model performance. So we're gonna do some visualization and we're gonna go through a very quick mini challenge as well. So please stay tuned and please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.